Have you ever looked at a really complex electrical circuit with multiple voltage sources, current sources, and resistors, and just wished there was a simpler way to understand what is happening at a specific part of it? It can feel overwhelming to analyze each component individually. Thevenin resistance, often denoted as RTH, represents the equivalent resistance of a linear electrical circuit when viewed from a specific pair of output terminals. It is a fundamental component of Thevenin's theorem, which allows us to simplify any complex linear circuit into an equivalent circuit, composed of just a single voltage source and a single series resistance connected to a load. The significance of Thevenin resistance lies in its ability to simplify circuit analysis. By reducing a complicated network to its Thevenin equivalent, we can easily determine the current and voltage across any load resistor connected to those terminals. This equivalent resistance essentially captures how the source side of the circuit looks to the load. It is measured by turning off all independent voltage and current sources within the circuit, and then calculating the total resistance looking back into the terminals. To calculate Thevenin resistance, you will typically follow a few key steps. First, identify the two terminals across which you want to find the Thevenin equivalent and remove any load connected to them. Second, deactivate all independent sources in the circuit, replace independent voltage sources with a short circuit, and replace independent current sources with an open circuit. Remember, dependent sources are left in the circuit as they depend on circuit variables. Finally, calculate the total equivalent resistance between the two open terminals. For circuits with dependent sources, a common technique is to apply a test voltage or current source across the terminals and then calculate the ratio of voltage to current, which gives you RTH. Understanding Thevenin resistance provides immense practical value. It empowers engineers to quickly predict how different loads will behave when connected to a complex power source. This is crucial for optimizing circuit design and ensuring efficient power delivery. Moreover, it is directly related to the concept of maximum power transfer, helping us determine the load resistance that will extract the most power from the source. Ultimately, Thevenin resistance is a powerful conceptual tool that distills a labyrinthine circuit into a manageable two-terminal equivalent. It transforms complex analysis into straightforward calculations, allowing for a deeper and more intuitive understanding of circuit behavior and making advanced circuit design accessible and efficient.